My name is Dominic Holden, and for my science fair project, I chose to investigate whether waste materials could be used in making a suitable brick alternative for buildings. Humans generate a lot of waste, which is a big problem around the world. A lot of these wasted materials are placed into dumps and are never used again. They can also take a very long time to decompose. Rather than dumping these materials, I wanted to see if they could be reused for something more useful, such as a brick. To determine which waste materials I would use, I researched what type of waste is generated in New Zealand. I also considered how long it takes to decompose, if it was safe to use and easily sourced. The waste materials I chose for the project were glass, polystyrene, rubber, and sawdust. For each waste material, I created 6 bricks. Each brick was made using the same consistent ratio of building mix, the waste material, cement, and water. I also created control cement bricks that would be used to compare against the waste material bricks. Once dried, each brick was measured and its weight recorded. To determine what type of test to do, I researched what characteristics made a good brick. As I would not be able to test all of them, I selected 6 that are important and that were possible to test using resources available. These were compressive strength, durability, weight, porosity, thermal conductivity, and ability to handle extreme temperatures. I don't have time to describe all the tests I did, so I'm going to focus on 3 of them. The compressive strength test was used to determine which brick was the strongest by finding out how much force was required for each brick to reach its breaking point. To test this, I constructed a lever device made of a bar and a pivot point. This meant I could use small weights to apply large forces. Set weights were added continually until bricks failed to withstand. To see how well the bricks performed with extreme changes in temperature, I performed an experiment that would recreate freeze-thaw conditions. Using half of a brick created from the compressive strength test, I completely submerged it in a bucket of water, leaving it to soak for 48 hours so that the water could get into all the cracks inside the brick. I then placed the soaked brick into the plastic bag and placed it in the freezer for 48 hours. This allowed for the water inside the brick to completely freeze and expand. I then took the brick out of the freezer to thaw for 24 hours. When the ice melts, it contracts, potentially leaving behind larger cracks in the brick. The brick was examined to make sure there were no flaws in it, and the plastic bag captured any debris that may come off the brick. I repeated this experiment 2 more times for each brick to simulate the freeze-thaw effect. The thermal conductivity test was used to measure a brick's ability to conduct and transfer heat from one side to another. This test was conducted using an electric frying pan and a digital thermometer. The frying pan was heated to a preset temperature. I then measured the temperature at the top of the brick before placing it in the frying pan to be heated for half an hour. During the heating process, I recorded the top of the brick's temperature every 5 minutes. After half an hour, the brick was taken out of the frying pan to cool. Temperatures were measured at 5-minute intervals over the course of an hour. The results were then recorded and graphed. Based on the results from the experiments, I concluded that the control brick was easily the best with a breaking point of around 1,000 kilograms, no change in the freeze-thaw, kept its temperature and thermal conductivity, and was very durable. When comparing just the waste material bricks, both the glass and polystyrene bricks proved to have the best potential. In some tests, they even performed better than the control brick. The glass brick was the most durable and the strongest of the alternative bricks, though it weighed the most and did not perform well in the freeze-thaw test. The polystyrene brick performed well against the strength, temperature, and porous tests, and was the lightest brick made. It was, however, the least durable brick. The glass and polystyrene bricks have characteristics that would be ideal in several building scenarios. Polystyrene bricks would work well at keeping dampness at bay and would be ideal when trying to keep transport weight down, while glass bricks would provide a hard wearing surface. I believe that the polystyrene glass bricks have promise and should be further researched. Thank you for listening to my presentation.